Welcome to a new part of the ISM Statistics 1 exercises. This time with an exercise on scale levels. Let's take a look at the exercise. Find for these characteristics the corresponding scale or scale level. Let's start. First off, we have weight in tons. Well, obviously we can order two things according to their weight. We can measure the differences in weight. We can say this weighs 200 grams more, weighs 5 tons more or less than something else. So it's an interval scale. And we can also say, well, this weighs double as much as something else. We could also, or we also have an absolute minimum, an absolute zero, which means this weighs 0 tons. There's nothing possible to say like this weighs less than 0, so this is an absolute zero, making this a ratio scaled variable. It's a little bit different with the next one, with closing sizes as in S, M or L. Obviously we can order them. We know L is larger than M, is larger than S. But then again, there are some pieces of clothing where not necessarily S is as far away from M as, for example, L is as far away from XL. Meaning, we could order them, it's ordinally scaled, but we cannot actually measure the distance between the two of them. So it's not intervally scaled, making this only ordinal. Then, for the third one, page length of a newspaper. Well, obviously we can say this newspaper is twice as large, has a twice as large page length than another newspaper, and we could say it cannot become negative, so there's an absolute lower bound, an absolute zero, making this a typically ratio scaled variable. Leading us to Windows versions. Windows versions have different possibilities. We have Windows servers, which is clearly outside of the spectrum, making this more or less a nominal scaled variable. On the other hand, if we exclude something like Windows servers, we have the classical 1.0, 3.1, 3.11, 95, somewhere then 8, 8.1. So yeah, we can order them, but it doesn't make sense to say this version is as much away from that version, or is the distance can be measured in any reasonable way, leading back to the version number. Therefore, we have an ordinal scaled variable, but we do not have an intervally scaled one. So we could say here it's ordinal if we only consider the normal versions. If we include something like server, it could be considered only nominal. Let's keep it at this and carry on with study programs at the university. Obviously, if I compare chemistry and mathematics, I cannot say anything like this is more of a study program than another one, making this a typical nominal scaled variable. Then we have the Richter scale for earthquakes. The Richter scale is a logarithmic scale, meaning an earthquake of strength 7 is more severe than an earthquake of strength 6. However, the difference between 6 and 7 is not the same as between 0 and 1, because for each level it increased by a factor of 10. Meaning we have an ordinal scale, but it's not intervally scaled, as we cannot interpret sensibly the distances. Then we have the intelligence quotient. The intelligence quotient, well, obviously was designed to rank people according to their intelligence, so it's an ordinal variable. Then we can carry on. It, however, doesn't make sense to say someone whose IQ is double the size than someone else is double as smart. We can do this with a very easy example. There's like at most 1 or 2 people in all of the world with an IQ of 200, whereas there's quite a lot of people with an IQ of 100. So it means that the guy with 200 is way more intelligent than a guy with an IQ of only 100. So this is not ratio scaled, it's ordinally scaled. And the advantage of the intelligence quotient, we can however say how far the distance is. So the distance between 90 and 100 is comparable to 120 and 130. Therefore, this is not only ordinal, this is also intervally scaled. Leading us to fashion designers. While some journals, some newspapers try to say this is better, this is more of a fashion designer than someone else, in general, we cannot really rank them only by being fashion designers without introducing additional characteristics, but we cannot rank them with fashion designers, making this typically only nominal. Then we have second to last, the space on a hard drive. This is relatively easy. We can say, well, here I have a hard drive, I have a second hard drive which has twice the capacity, twice the available space, making this typical example for ratio scale. Particular, we also have a natural zero, an absolute zero here, meaning a hard drive with no space at all. Leaving us with the last one, characters in a book. Here characters as in different signs, not as in specific persons. Therefore, well, there's a limited number of characters. I could say, however, this book contains twice as much characters as a different book, contains less, twice as much, 3 times as much, half as much. Or I could just take a look at the blank book having no characters at all. It's not possible to have a book with less than nothing. Therefore, we have an absolute zero, making this a ratio scaled variable. Well, this then concludes this exercise. I hope all of you have enjoyed listening and learned something. Until next time, see you and goodbye.